Here is something hopefully you will never run into, but someone had a question and they were wondering why their stair treads weren't lining up with the risers, why they weren't square. And this is probably going to be the reason. And how do I know? Because this is something that I ran into a lot while building stairs when we worked on the tracks. And when we worked on the tracks a long time ago, this would have been the late 70s. And early, well, through the 80s, the stairs would be, the building foundations weren't perfectly square. The layout for the walls wasn't perfectly square. And of course, that would translate down to the stairs not being perfectly square. So let's go ahead and start with a gap here. And I'm just putting a gap here to give you an idea. This will make sense here when you watch a little bit more of the video, but I'm going to move the stair stringers an inch away from the ledger and just so this one here, the ledger is square, the deck up here is square. The only thing that isn't square now will be the stringers, all four of the stringers here. And here's what happens if we're using 2x6 for our treads. And again, some of you might have experienced this while building something, a set of deck stairs, or even in a house. And you can see here where the 2x6 is square. It's at a 90-degree angle. But as you stick it up against the back of the stringers and try to get everything to line up, it's not going to look good. And that's just simply because the stairway is out of square in one direction or the other. So again, you'll have it to where the back might be even with a stringer, and then you have it here where there is a gap between the edge of the stringer and the tread, or if it's going in the other direction, then the gap that we'd be looking at here would be in the back, and this where it's even with the stringer would be in the front. And you can see here where it looks even worse with the larger lumber, something that's full length. The problem's going to look a little worse depending upon how far out of whack it is. And here's what it would look like on the other side. You'd be tight at the back, and then it would be overhanging. So on one side of the project, it might not look as bad as it will on the other side, depending upon how far out of whack it is. So here we have a straight line. So I kept everything straight. You're probably thinking, now wait a minute, this is moved over. That could be the case, but that's not the case here. This wall is out of whack. So these lines are perfectly straight. This wall is perfectly straight. I have my gap here. And then when I move the wall over to fill everything in, because this is the situation you would be looking at. The lines are straight, but now we have an inch larger gap at one end than we do at the other end. So again, this would have been perfectly square if the wall was actually parallel to the square line. A top view of it here, and again I left the decking material square to give you an idea of what we did. We just simply moved this part of the wall out a little bit to make it out of square. But, you know, these lines are straight. We're dealing with straight lines here and a square line in the back. It's just that the wall here would have been laid out incorrectly. And this stuff happens. That's why we're always double checking measurements. And hopefully, I should say. Now, for those of you who aren't quite getting what I'm actually talking about, I went ahead and drew a perfectly square stairway if we were looking at it for a floor plan view. So here's our stairway, our three-dimensional drawing. This is just a two-dimensional drawing where everything is square. Each corner has a 90-degree angle and is square to the lines that are running perpendicular to each other. Over here, this isn't the case. Instead of having a square platform, we have a 1 inch. The platform, the wall, the landing here is off just a little bit. And then when we attach our stringers to that, then it produces something like this. So these treads have 90-degree angles on them. They're cut square. You know, like I said, you could always cut these individually to allow for this, to allow for the problem. And if you're going to use carpeting, that's not going to be a problem. Hardwood flooring and stuff like that, your finish guy is going to hate you. They are not going to appreciate this. So again, a 1-inch difference. This side of the landing is 37 inches. This side of the landing is 36 inches. And then it produces something like this. Now let's go ahead and take a look at another situation that you could run into to where you have a square landing, but you have a wall that might be off a little bit. Now here I'm probably off about 2 or 3 inches. I'm just drawing it for effect. But this is what happens, same kind of thing that we've seen in the other diagram, where we just have the treads and the risers, or the treads that aren't lining up again. So this is a line going in this direction that's not perfectly straight. And here's what it would look like if it was going in the other direction. So I did this to a little extreme, but if you're off, you know, a 1/2 inch or 3/4 of an inch in 4 feet or something like that, in maybe 3 or 4 treads, you could actually see a variation of this. So anyway, hope that you learned something from the video here. This is a problem that, like I said, I ran into plenty of times years ago, when people either didn't pay that much attention or had to deal with what they had to deal with.